In last lecture, I explained how to solve non-homogeneous equation of the first degree in x and y and also give one example on it. Now in this lecture, I give one more example on non-homogeneous equation of the first degree in x and y. Now consider the example. Example, solve y minus 3x plus 3 dy by dx is equal to 2y minus x minus 4. So solution, the given equation can be written as dy by dx is equal to 2y minus x minus 4 divided by y minus 3x plus 3. So this is equation number 1. Now this is a non-homogeneous equation of the first degree in x and y. So by our method, first of all putting in place of x is equal to x dash plus h, and in place of y as a y dash plus k, where h and k are constant. Then the given equation become dy dash by dx dash is equal to 2 into y dash plus k minus, putting the value of x dash plus h, minus 4 divided by y dash plus k minus 3 into x dash plus h plus 3. So now we have to multiply 2 to the bracket, also minus 1 to this bracket, and here on the denominator also we get 2y dash plus 2k minus x dash minus h minus 4 divided by, we get y dash plus k minus 3x dash minus 3h plus 3. Now this is equation number 2. Now we have to putting the 2k minus h minus 4 equal to 0 and the k minus 3h plus 3 equal to 0 for finding the value of h and k. So putting k minus 3h plus 3 is equal to 0, k minus 3h plus 3 equal to 0. So this is equation number A, and 2k minus h minus 4 equal to 0. This is equation number B. This is 2k minus h minus 4 equal to 0. Now solving these equations for h and k, we get the value of h and k is, so this is the, we have to simultaneous solution of equation we are doing here. I solve here this example. So we get the value of h and k. So for that we have to multiply equation A by 2. We get 2k minus 6h plus 6 is equal to 0, and multiply equation B by minus 1. So we get minus 2k plus h plus 4 equal to 0. Now add these two terms, then 2k cancel with the minus 2k, and here we get the minus 5h plus 10 is equal to 0. From that we get the value of h is equal to 2. Now putting this value in equation A, putting this in equation A, we get, after putting this value, h is equal to 2 in equation A, we get the value of k. So we get the value of k is equal to 3. So thus we get the value of h and k are the 2 and 3. Therefore equation 2 becomes, therefore equation 2 becomes, so we have to putting the value of h is equal to 2 and k is equal to 3 in the equation 2, we get here dy dash by dx dash is equal to 2y dash plus minus x dash divided by y dash minus 3x dash. So this is equation number 3. Now this is a homogeneous in x dash and y dash, and therefore solvable by the method of equations homogeneous in x dash and y dash. So by this method we have to putting y dash is equal to vx dash, equation number 4. So we obtain, so we have to putting this value y dash is equal to vx dash here. Before that we are taking the derivative of this with respect to x dash. So therefore we get dy dash by dx dash is equal to v plus x dash dv by dx dash. So equation number 5. From equation 3 and 5, the left hand side are the equal, and therefore right hand side must be the equal. So from equation 3 and 5, we get v plus x dash dv by dx dash is equal to 2y dash minus x dash divided by y dash minus 3x dash. Now from equation number 4, putting the value of y dash is equal to vx dash here. So we get, now from equation 4 we get v plus x dash dv by dx dash as it is. So putting the value 2 into Vx dash minus x dash divided by Vx dash minus 3x dash. Now taking common x dash from the numerator and denominator, we get, now cancel the terms x dash to the x dash, we get here 2v minus 1 divided by v minus 3. So therefore here we have to taking v to the right hand side, we get the minus. So on the left hand side we have only x dash dv by dx dash is equal to 2v minus 1 divided by v minus 3 minus v. Now simplify this, we get 2v minus 1 minus a v square plus 3v divided by v minus 3. So that is equal to, we get minus v square plus 5v minus 1 divided by v minus 3. Now separate the variables. Separate the variables. We get v minus 3 divided by taking minus 1 common from v square. So in the bracket we get v square minus 5v plus 1 dv is equal to dx dash by x dash. Now it implies, now taking this term to the right hand side, we get v minus 3 divided by v square minus 5v plus 1 dv plus dx dash by x dash is equal to 0. Now we have to write this equation as 1 upon 2 into 2v minus 5 minus 1 divided by v square minus 5v plus 1 dv. We have to only make changes here. So after simplifying, we get the same value v minus 3 plus dx dash by x dash is equal to 0. Now we have to split this equation. We get therefore 1 upon 2 2v minus 5 divided by v square minus 5v plus 1 dv minus 1 upon 2 1 upon v square minus 5v plus 1 dv plus dx dash by x dash is equal to 0. Now we have to take this term as it is, but add and subtract here 25 by 4 so that we get the value of v square minus 5v plus 25 by 4 is a v minus 5 by 2 square. So therefore we get 1 upon 2 2v minus 5 divided by v square minus 5v plus 1 dv minus 1 upon 2 into 1 upon v square minus 5v plus 25 by 4 minus 25 by 4. We have to add and subtract this term, plus 1 dv plus dx dash by x dash is equal to 0. Now the value of this is v minus 5 by 2 square, and value of this is 21 divided by 4. So we get here we have to multiply 2 to the whole equation. We get 2v minus 5 divided by v square minus 5v plus 1 dv minus 1 upon v minus 5 by 2 bracket square minus under root 21 divided by 2 bracket square. Value of this dv plus 2 dx dash by x dash is equal to 0. So we have to making two things here, that is the multiplying 2 and also simplify this. Now we get, therefore 2v minus 5 divided by v square minus 5v plus 1 dv plus 2 dx dash by x dash is equal to, now taking this term on the right hand side, we get dv upon v minus 5 by 2 bracket square minus under root 21 divided by 2 bracket square. Now integrating this, we get integration of this value is log of v square minus 5v plus 1, and value of this is log of x dash plus integrating constant log c is equal to, now integration of this is 1 upon 2 into under root 21 divided by 2 into log of v minus 5 by 2 minus under root 21 divided by 2 divided by v minus 5 by 2 plus under root 21 divided by 2. So for finding the value of this integration, we use the formula as, since integration of f dash x divided by f of x dx is equal to log f of x, and integration of 1 upon x square minus a square. So this is nothing but the x square minus a square form. Dx is equal to 1 upon 2a log of x minus a divided by x plus a. So using this formula to finding the integration of this term, and for these two we are using this formula. So 2 gets cancelled here, Now using the rules of logarithm, we get log of v square minus 5v plus 1 into x dash square into c is equal to log of, here we have to simplify this term as well as this term and cancel 2 to the 2, we get 2v minus 5 minus under root 21 divided by 2v minus 5 plus under root 21 raised to this value 1 upon under root 21. So taking the anti-log of both sides, we get c into x dash square into v square minus 5v plus 1 is equal to 2v minus 5 minus under root 21 divided by 2v minus 5 plus under root 21 raised to 1 upon under root 21. So this value we have here. So therefore we get now we have to substitute the value of v as y dash divided by x dash, since we have to consider here the value of from equation 4, y dash is equal to v into x dash. So putting the value of v as a y dash divided by x dash. So substituting v is equal to y dash divided by x dash in above equation, we get cx dash square into y dash square divided by x dash square minus 5 y dash by x dash plus 1 is equal to 2 into y dash by x dash minus 5 minus under root 21 divided by 2y dash by x dash minus 5 plus under root 21 raised to 1 upon under root 21. Now we have to simplify this. We get therefore c into x dash square into y dash square minus 5 x dash y dash plus x dash square divided by x dash square is equal to, now again here we have to simplify and cancel x dash to the x dash. We get here value is 2y dash minus, taking in the bracket 5 plus under root 21 into x dash, because we are taking the x dash common from these two terms after simplifying, divided by 2y dash minus 5 minus under root 21 into x dash raised to 1 upon under root 21. Now here cancel x dash square to the x dash square. Now we have to putting the value of y dash and x dash in y and x, because our original given differential equation is in the x and y, so solution must be in the x and y. So therefore, substituting the value, we get c into y minus 3 square minus 5 into y minus 3 into x minus 2 plus x minus 2 bracket square is equal to, now here we get the 2 into y minus 3 minus 5 into minus, we have to, here term is this, so 5 plus under root 21 into x minus 2 divided by 2 into y minus 3 minus 5 minus under root 21 into x minus 2 raised to 1 upon under root 21. So reason is that since we have x is equal to x dash plus h, and putting the value of h and value of x dash is from this equation x minus h, it implies x dash is equal to x minus 2, since h we have to 2, and y equal to y dash plus k we have to substituting. So from that we get the value of y dash is y minus k, but the value of k is 3, so we get y dash is equal to y minus 3. So therefore in place of y dash we have to putting the y minus 3, and in place of x dash we have to putting x minus 2 here. Now simplify this, we get the solution. So therefore c into, now taking the square of this, we get y square minus 6y plus 9 minus 5 into, now multiply y minus 3 to the bracket x minus 2, we get the xy minus 2y plus minus 3x minus minus plus 6 plus, now taking the square of this, x square minus 4x plus 4. Now this is equal to, now this term we have get 2y minus 6, we have to multiplying 2 to the bracket, now multiply minus 5 to the x minus 2, and then minus 21 under root 21 to the x minus 2. Similarly, take the procedure of this on the denominator, we get, so minus 5 x minus 2 minus under root 21 into x minus 2 divided by 2y minus 6 minus 5 into x minus 2 plus under root 21 into x minus 2 raised to 1 upon under root 21. So therefore we get c into y square minus 6y plus 9 minus 5xy. Now multiply my minus 5 to the bracket. We get plus 10y plus 15x minus plus minus, we get a minus 30 plus x square minus 4x plus 4, that is equal to 2y minus 6 minus 5x. Now multiply minus 5 to the bracket. So plus minus minus plus 10 minus under root 21x plus 2 into under root 21 divided by, we get 2y minus 6 minus 5x plus 10 plus under root 21x plus here we get the minus 2 under root 21 raised to 1 upon under root 21. Now therefore we get c into y square minus 5xy plus x square. So these three terms here taking. Now we have to taking x common from these two terms. So we get here plus 11x. Now taking y common from these two terms, we get plus 4y, and from the remaining, that is the plus 9 minus 30 plus 4, we get the value is minus 17. That is equal to, we have 2y. Now here taking x common from these two terms, we get minus x common, we get 5 plus under root 21. Now the from minus 6 plus 10 plus 2 under root 21, we get here plus 2 common, 2 plus under root 21 divided by 2y as it is. Again we have to taking minus x common from these two terms, we get minus x into 5 minus under root 21. Now from minus 6 plus 10 and minus 2 under root 21, we get 2 in the bracket, 2 minus under root 21 raised to 1 upon under root 21. Now which is the required solution? So this is an example of non-homogeneous equation of the first degree in x and y. On the next lecture, we have to take another type, that is the exact differential equation.